Okay, hello, good afternoon, everyone. Please take a seat. So now let me start the afternoon session. This is the last session for the Ethernet Tech Day. The session title is PHY, switch, and microcontrollers. And we have the totally 4 presentations, and including coffee break. And please just remind us, please mute your mobile phone and also similar electronic devices during the session. And also, each presentation will be 25 minutes, and then 5 minutes Q&A. Okay. So let me introduce the first speaker and title. And the title is Optimized Ethernet Switch Hardware Software Collaboration for New EE Architectures. And the speaker is Illia Safiulin from the Elektrobit. Welcome, Safiulin.
Well, it's honestly a pleasure to be on the stage for the second time, and it's a big honor. Thank you a lot. And today, I will be talking about the optimized software for the switch, and actually the collaboration with the switch hardware for new E2E architectures. Presenting in the second day, it's quite beneficial because I can skip a lot of topics because there were very big amount of very good presentations yesterday and today, so I will be clicking very quickly through some of the slides. So I would like to skip the part of introduction of the zonal architecture with challenges and with benefits of it. But I want to point out here one thing. So in the zonal architecture, the importance of the network nodes, it's the elements in the network which are inside of the network, in the middle of the network, is very high. That is why, in order to cope with those challenges where like reuse of hardware and software, like anything and anywhere, that information can be obtained from all domains if it's allowed by configuration, it requires a special software on it. So if you look at the network node, usually, let's say there is a microcontroller, which is a host, and a switch, right? And switch, it's not anymore a dummy and simple peripheral. It's an advanced network device with a lot of features inside. And those features, which can help, some of those, will be listed here right now. And they're extremely helpful for new E2E architectures. They're extremely helpful to reaching and meeting the requirements. And first of all, modern switches, all of them, they have their own CPU system inside. They also support TCOM, which is extremely useful tool. Also, the TSAN features are included. In some switches, there are HSM as well. Health management, it's possible to obtain from the registers how many frames are dropped, what is the temperature of the PHYs, internal one, for example, and so on and so forth. There is 10-based T1S, TC10, MACsec support, and also possibility to include the advanced cybersecurity techniques. And all of that in the switch. However, in order to squeeze out the maximum functionality and performance out of it, we need to have a special and very, let's say, optimized software on it. Before talking on the software, we need to clearly know what is available in the hardware. So, and in my presentation, I will focus on multiple parts here, on multiple topics, not all of them. It would be too long. So I would like to focus at first on the general software. How should it look like? Also, I will quickly show you, for example, how the health management can be done efficiently, how the MACsec can be included, and also how the advanced cybersecurity can be integrated. So before, what is available in the switch in terms of hardware? If you look on the right side, there is IRM core, there is a switch switch engine inside with the TCOM stuff, maybe with some PCI Express extended functionality. Also, there is some Ethernet controller, registers, boot engine, and so on and so forth, and even sometimes HSM cores. Additionally, modern switches, they have from 4 up to 16 ports or maybe more in the future. The speeds, they support the speeds from the 10 megabits up to 10 gigabits with various interfaces up to US XGMII. Very broad spectrum. Host interface for control and configuration, we can choose from SPI up to PCIe generation 3. Enormously high bandwidth. However, and this, however, is very important, we should keep it in mind. From the CPU perspective, there are still IRM-based real M500 cores. Yes, there are some switches with R52 inside, which are a bit more powerful. But if we look at the internal memory, there are some, let's say, some borders which has to be considered. So keeping in mind the features, the functionality, and the hardware capabilities, what type of software can be done here? From one perspective, of course, all known, multiple times mentioned today, there is a generic software based on AUTOSAR, which is like pieces of Lego from which you can build whatever you want. Very good one concept. It's well-established models, high reuse, known protocols, configuration workflows, all of that is established. However, the disadvantages here that the hardware-specific features are not fully supported. Software footprint might be very high, remembering the constraints. And also the configuration and integration efforts for integrators. Because if you consider one ECU, and then suddenly, besides the microcontroller, you have also an AUTOSAR basic software on the project, on your switch, it means you have to do 2 times the integration projects. Then, what else? What is another alternative? Another alternative might be to have an optimized switch software compliant to the AUTOSAR protocols or interfaces. One of the examples, let's say we want to quickly participate in a drag race, but we don't have a car. We don't start from buying some tires or the whole engine and assemble everything. We buy something, we change the tires, and here we go. We use it. Coming back to the switches, so with optimized software, what we can do, we can get the maximum performance because the software is optimized for a certain hardware feature, for certain use cases. It has a small software footprint. It is pre-integrated. Disadvantage, of course, it's not that easy to build this software because a very strong collaboration and partnership between the software providers and the switch vendors is a must-have. Another example. At home, in your router, you don't have Windows, right? You use a special firmware. So there are some constraints, or not constraints, let's say there are some doubts in the industry that maybe specialized software will require special interfaces, which interoperability topic is very important. So it's a bit dangerous. In our recent research together with Renesas, we presented results in Automotive Ethernet Congress. We showed that using the optimized software is quite beneficial in terms of performance. So performance increased by a factor of 100, it's something significant, I would say. What we did with Renesas, we used on their hardware accelerators, we used special software for that hardware accelerators, and that software was integrated into AUTOSAR environment, was configured with AUTOSAR configuration tools we used at Elektrobit. Coming back to the switches, update configuration notification, even in the case of special optimized software, which supports the AUTOSAR protocols, it still can be achieved. Now coming back to the next topic, not back, but yeah, health management. If you consider the combination of the microcontroller and the switch, and you have a health monitoring application on your switch or on your host running, sometimes you really want to know what is the link states, what is the temperature of the device, maybe we are in overheat, how many frames did we lose, and so on and so forth. And it is usually done by microcontroller reading each of the registers for a specific port, which is hardware dependent, so the application needs to know which registers to read. And it's also a resource and time consuming because, for example, if you want just to read link status per port, per single hardware port, you need to perform 2 register readouts, and it's time consuming because there is a lot of idle time. What can we do? The solution is to do it locally. If you have a software which knows how the hardware is running, what are the registers, you can do it locally, you can get the data locally, it's faster, it's simpler, and also you can, using the standard or well-known protocols like TCP/IP, to provide the data either asynchronously or synchronously on whenever there are some changes in the, let's say, changes in the states to the host microcontroller. And then by this, and it's also we can protect this communication. And by that, actually what we can do is that we can provide a separation because you can reuse the same application in the other project. I mean, applications in the microcontroller. On the other project where you use a different hardware, because by providing the services, we decouple the application from the network. We decouple the microcontroller from the switch. And by the way, using the well-established protocols, we can do it both in classic and adaptive AUTOSAR. So the message here, don't micromanage, delegate. MACsec. I will not go into details about the MACsec and other protocols, but what I wanted to say, that there are some key parts included in this, like MACsec key agreement, different association, encryption, check value, and so on and so forth keys. And there are different ways how to implement the MACsec. So typical startup time in automotive networks is around 200 milliseconds for the Ethernet. In order to establish a secure communication, we need to use the MK protocol and EAP to share the keys, right? And in recent studies from Technica, please correct me afterwards if I was wrong, there was shown that the typical time of MK was 23 milliseconds, which is fine, yeah, but it was for one direct link. And the question is, what to do with the switches when you have 16 ports, which has to be support MACsec? How to deal with it? So with my colleagues, we had a brainstorming session, how we can do it, and there are some tweaks possible, both on the protocol side and also in, with the hardware. For example, first of all, we should do the switch MK key as a server by definition. That's the first point. And the second point, we need to use the pre-shared, the key and ICK, because from the dynamically derived keys, we should come to the statically derived keys. And by then we will reduce the, let's say, the key generation significantly. The next one, it was a quite funny part. If you look at the standard, there is one big formula how to calculate the SAK. And then on the same page, one line saying, well, actually you can use a random number generation from the HSM to implement the to calculate or generate the SAK, which is, well, why not to do it? And then as well, when we have the SAK already available, the EAP SAK assignment message also can be pre-calculated, which means so we can do the statically derived, the ICK and KEK. We can quickly calculate SAK and the EAP SAK assignment message. And by the way, in the Ethernet connection, we have some link initialization time, which is a special thing for the PHYs. But actually, if we have a HSM in the switch and there is some intelligence inside of the switch, we can do some things in parallel. we can do SAK generation and the message in parallel to the link initialization, which can significantly decrease the startup time for the max secure communication. One small remark, a processing time of other protocols was not considered. Yes, and now, finally, advanced cybersecurity. We've heard a lot yesterday about cybersecurity and today and also during the panel session. And I want to bring a couple of points here as well. Because why do we need cybersecurity? I will not mention. This is clear. However, the question is, why do we need a cybersecurity inside of the switch? And there are multiple answers to this question. So if for example, IDPS stands for Intrusion Detection Prevention System or Deep Packet Inspection Technique whatsoever, included inside of the switch, it means that you have a firewall or something like that, advanced firewall, right in the middle of your network. Right in the middle of your network. You can say, which leads to early detection and prevention of the unauthorized traffic. You can detect way more attacks if you have your protection in the firewall, in the middle, rather in the end node. On top of that, if it's already integrated, the integration effort is way smaller. Okay, somebody can say that this deep packet inspection requires a lot of computational power. True, fully agree. But there are some things which we can do, especially in the switch. So how does it work in general? Let's consider IDPS usage for some IP whitelist. There are different, not all, but some different protocol fields. And then, for example, how does it work? So okay, we receive the frame. Let's see what is the destination MAC. Is the source MAC allowed for this destination? Is the Ethernet type allowed for this destination and source MAC addresses, whether the VLAN tag is, and so on, so on, and so forth, up to the some IP message type, or maybe deeper, depending on what you want. So it's very flexible. It's secure, precise. However, if we do it blindly in software, it's slow. Now, what can we do if we have it in switches? So first of all, or in general, first of all, there are, as I said, multiple tricks. First trick is on the configuration level. You need to think in advance, what do you want to check? Do you really want to check with this deep packet inspection engine all the traffic? Or maybe you need to check only the traffic which goes from one security area to another one. It's the first part, and by that you can already reduce, let's say, computational efforts. And the next part is, remember the switch hardware features, the TCAM rules. Actually, if you have a proper integration of this IDPS, proper integration with the TCAMs, then some parts of the frame, according to your rules, can be checked already in hardware with full line speed. And the remaining only can be checked in the software. Or, for example, if your switch support the offsets of the TCAMs or the split of them, then actually you can go even deeper to do even more parts in hardware and even less parts in the software. And this can lead to enormous performance improvements. Enormous, because again, remembering, constraints in the CPU power in the switches. And I think I'm pretty fast with my presentation. Finally, the summary. What to remember, what to think, what to keep in mind. First of all, Ethernet switches, it's not a dummy peripheral anymore. It's a complex device with special hardware feature which require a special software, and they play a key role, or one of the key roles, in the in-vehicle communication. Yesterday, we've seen a lot of presentation about zonal architecture, and everywhere there was a switch, 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 switch. And there is a reason behind it. Then, what about the software? So, with a smart and innovative software, which is optimized for a certain use cases, optimized for a certain hardware, we can not only use the full hardware functionality, and support out-of-the protocols interfaces. We can also provide a special separation between the network from the hardware. We don't need to have a deep integration of your switch hardware into your application. The MagSec startup issue can be defeated. It was one proposal. Maybe there are other ones more efficient. Would be really happy to see it. And by using the protocol fix and also the hardware acceleration. And finally, the cybersecurity can be efficiently integrated. We can, so those UNR or some Chinese or other regulations which will definitely pop up in the future, those regulations can be easily supported, and by a single protection or single protection engine in the middle of your network, you can reduce your cybersecurity complexity on your end nodes by a significant amount. That's it from my side. Thank you for your attention.
Okay, thank you, Illia, for your nice, interesting presentation. Now, open Q&A for the audience. Oh, yes, please.
Again, this is Jill Huang from Delta Electronics, and a very nice presentation. And one of the questions I have is that you build a lot of the functions in the switch, and the cost of a switch itself will be very high if you want to support all those features. And especially you move some of the functions from the MCU to the switch itself, and that adds some cost. Also, the second thing is that you're going to have the functional safety. Will you consider functional safety in the switch? Thank you.
Okay, thank you for a very nice question. So, starting from the cost, let's put it this way. In some architectures, you have to use a switch, no discussion. And as far as I remember, there are almost no switches without embedded CPU right now, from all switch vendors. All of them, they have it. It's the first point. And then having an embedded CPU or some additional feature, it's an opportunity to reuse them. It's an opportunity to offload some tasks from the microcontroller, put it on the switch. It's the first part. Then, what was the second part of your question? I'm sorry.
Functional safety.
Functional safety, yes, yes. Functional safety, it's a tricky point here. From one side, what we know is that communication is considered as QM, no functional safety considered. However, right now, we see more and more requests coming for example, ASIL B, ASIL beta. First of all, what we need, what I can tell you from a supplier point of view, is that we need for which application, what is required to be ASIL B? It's my first question. Then the second question is, if the hardware can do ASIL B, because if the hardware is not capable, or in the safety case of the hardware, let's say safety manual of the hardware, that one is not considered. It might be very tricky to do it in software as well. But in general, let's put it this way: if we can do by using, for example, a safety OS or maybe some tweaks on top of that, it is possible to achieve an ASIL B in combination of hardware plus software.
Thank you.
Okay, any other questions? Nothing? Or may I ask one question?
Yes, of course.
Please go back to the page 6.
Oh, I need to click a lot.
Yeah, this page shows a comparison between the general OSA and optimized Ethernet switch specific OSA. So what do you think about the comparison between this Ethernet switch specific OSA and non-OSA?
And no, not
No, not AUTOSAR. So basically, so sometimes another one of the options, not AUTOSAR is one of the options.
Yes. So, I mean, my opinion is listed here. I mean, AUTOSAR is a good example, but it was designed for reusability, right? That the same block can be used in different hardware. Yesterday in panel session, what I said that we are at the level we are only using the hardware separately from the software. We are hitting the ceiling with the performance. It's already at the limit, which means that before it was like that. So it's separated, hardware from software, AUTOSAR, all of that. But for certain application, not everywhere, just please don't get me wrong, not everywhere, but for certain application where high speeds, high performance is needed, the hardware and software should not like that. It should look like that. So there has to be a deep integration. And achieving that with AUTOSAR modules poorly might be quite tricky. And also, as I said, footprint, software footprint is a very important part. Because do we need an RTE? I don't know. Maybe for certain application, yes. For all, not sure.
Okay, thank you. Yes, Carl, please.
Hi, this is Carl Budweiser from BMW. So your basic proposal is to run something like a driver on the microcontroller to actually interact with the switch, make best usage and high abstraction. Mm-hmm. I've heard also different approaches here, and that approach is actually, I would like to ask you about your opinion on that. What about running AUTOSAR on the switch and let two AUTOSAR systems interact with each other? So even higher abstraction. What do you think about that?
Very good question. I can provide you one part of the answer. Then you can talk with the switch vendors about what is their opinion to put in classic AUTOSAR on the switch. You will get pretty similar opinion. So let's talk about how will those two AUTOSAR components talk to each other? Through some IP, right? Or through TCP IP?
Most likely, yeah.
Sorry?
Actually, I'm asking you, how is this supposed
to work? No. It's just like, so they will use the same protocols. And in the end, if it's the same protocol, does it matter much? What is behind it?
I would argue no. I like the more flexible approach better, actually. What you introduced, I like more.
More flexible, of course. Flexibility is very nice stuff, but then, as I said, for certain applications, this flexibility leads to degradation in terms of performance. And it's simply not enough. So
I guess future will tell which is the solution.
Of course.
Okay, thank you. So let's move on to the next presentation. So thank you, Illia. Yep. Nice presentation.